Welcome guys, today I'm going to be proving by induction that the sum of consecutive cubes to n is going to equal this formula, n squared times n plus 1 squared over 4. So let's begin. First we need our base case. We're just going to test 1 and see if it works. So 1 cubed should equal 1 squared times 1 plus 1 squared over 4. That's equal to 1 times 2 squared over 4, which is 4 over 4. 2 squared is 4. And that is equal to 1. 1 cubed is equal to 1. Perfect. So that holds true. Then our induction step. So what we need to do is prove that when this is true, that also implies that the case for n plus 1 is also true. So let's write it out. We need to prove that if the sum of consecutive cubes, when it is equal to this, that implies that the sum of consecutive cubes to n plus 1 is going to equal this just with substituted n plus 1. So n plus 1 squared times n plus 1 plus 1 squared, n plus 2 squared over 4. Alright, so let's do that. Notice how the sum of consecutive cubes to n plus 1 is just, let's write it out, it's just the same as the sum of consecutive cubes to n plus another n plus 1 cubed. So like this. 2n plus 1 I cubed is equal to the sum of I cubed to n plus another n plus 1 cubed. And for induction step, we believe that this statement is true. So we can just, all we need to do is check that our original formula, n squared times n plus 1 squared over 4 plus n plus 1 cubed is in fact equal to this formula. If that is true, then we have proof that when we assume that this formula is true, then it implies that the formula for the case of n plus 1 is true, and that will be complete. So let's see if it actually does match. It's going to be equal to n squared times n plus 1 squared over 4 plus, let's do some artificial substitution here, over 4. That is equal to n squared times n plus 1 squared plus 4 times n plus 1 cubed over 4. And notice how we can factor out n plus 1. We can even factor out n plus 1 squared. That's going to equal n plus 1 squared, because it's in both here, n plus 1 squared times n squared times 1. That's what we have here. And plus, we have 4. Here is n plus 1 cubed. We're factoring out n plus 1 squared. It's going to be 4 times n plus 1. Don't forget over 4. And if we simplify even more, we get n plus 1 squared times n squared plus 4n plus 4 over 4. And notice how n squared plus 4n plus 4 is in fact equal to n plus 2 squared. Remember that it is just a normal perfect square binomial. N plus 1 squared times n plus 2 squared over 4. And it is done, because we have in fact shown that when this statement is true, and when we add another n plus 1 cubed, it is going to be equal to n plus 1 squared times n plus 2 squared over 4. And so we have proved by induction that the sum of consecutive cubes is equal to this lovely form. Thank you for watching.